Hi everyone. So today we're going to discuss about a topic that you've heard of, probably you read about, and this topic has generated a lot of hype, and I want to see with us if we can find also reason for hope. So let's discuss about blockchain. First of all, a quick introduction of myself. My background is in engineering and I've been doing computer science for many years. I've entered the blockchain space and worked on several protocols, public blockchain mostly. I've co-founded multiple associations and events, hackathons, conferences in France. And I have two main projects that I wanted to mention here. One regarding healthcare and the usage of blockchain and cryptography to help people. And the other one that is a little bit lower level, which is about computing around private data. So how can you do calculation without disclosing private information? So we are going to start today with a gentle introduction to blockchain. Just for my knowledge, who here would say that they know about blockchain, they know what a blockchain is? Please raise your hand. Good. So the way I explain blockchain to people, especially when I don't know their background, is by using a small metaphor, the metaphor of a family. So imagine that you have parents and 4 children. In this family, there is one rule. Every child must do the dishes at least once a week. The parents, they have some power to make sure that this rule is applied. They can supervise the fact that the children are actually doing that. They have an authority, and they can also punish the children. But the children, on the other hand, they don't really care much about this rule. What they like are rewards. So they're looking for their own pleasure. They need to be motivated to apply this rule. The issue with that is trust. How can you know as a parent that your child did do the dishes and not his brother or his sister? How can you know when someone lies and pretend that they have done the task when it's in fact not true? So this generates an overhead for the parents, and they just end up being tired and having to do work, so it just didn't work. The question is, how can we help them? So that might not be obvious, but the parents decided to go to a store and buy a blockchain. What does it look like? Could be a tube that they go and bring into the kitchen. They put it in the ground so it cannot be moved. And then they give tokens, small tokens. Each child has its own color, and they give them a padlock and a key. The tube entrance has 4 places where you can put the padlock. And if you want to insert a token in that tube, you need to have at least 2 padlocks open, just to physically be able to put the token. But there is a trick. As you can see, if I want to say that I've done the dish and want to insert my token, I cannot do it alone. I need someone to say, yeah, I agree, I've seen you, you've done the dishes. So I cannot insert a token in this tube by myself. I need a consensus with my brother and sisters. The good thing about that is when parents, they come, they only have to look at the tube. They don't have to ask any question, they don't have to supervise anything. They just go in the kitchen, take a look at the tube, they know if the dish were done, they know who did that, they know at which frequency, they have all the information just by walking by the tube, not even interacting with it. We actually had this tube brought to one of my hackathons in Paris, and we used it to explain blockchain to people. And the metaphor is about saying, this was just a simple representation, but what blockchain can do is bring the same brother and sister that we saw in this family to society, to people that have to collaborate on a task but don't necessarily trust each other and are afraid of risk of corruption or fraud. So here I'm going to introduce to you a mapping of what we saw. When we talk about the family, really what we're talking about is an ecosystem of actors. The rule that needs to be respected is a smart contract or a protocol. The parents, they represent a central authority. They have all the authority in this scenario. And the children, they represent the peers that forms the network that are here to do the job. Those people need to be incentivized. Otherwise, they won't do the job or they will do it poorly and maybe lie. And the trust issues that we saw before are the attacks that are possible on the network in a blockchain if a node decides to send fake transaction or to validate transaction that don't respect the protocol. And then the question that we ask about the parent, how to help them, becomes for many businesses and services and even banks, how can we disrupt them? How can we decentralize those services? Here, well, I guess you've seen that the transparent tube is because of the transparency of blockchain. We always say that blockchain are transparent. And this is what I told you about just walking by the tube and seeing all the information without even having to do anything about it. This is what blockchain offers. You have a distributed ledger, you have all the transaction, the timestamp, all the information, and if you are connected to that network, you can just get this information. There is no black box, there is no centralization. You don't need to be in a certain company and have access to that database to have the information. It's open for everyone to see. The tokens are just basically representative of the transaction or the blocks, depending on how you want to see that. The fact that the tube is in the ground is a metaphor of the hash. So for those who don't know, hashing functions are used in the blockchain to link blocks between each other, which is why we call it a chain. So each block contains the hash of the previous blocks. And so if you want to modify the content of a block, the hash is going to change. And so you have to change also the content of the next block and the next block and the next block. So if you want to modify one block because it changes its hash and its hash is contained in the other one, then you have to change also the other one and the other one, which create a cascade of modification. And at the end of the day, that's one of the reasons why blockchain are secure. It's going to take you so much time and so much computation resources that it won't make sense and won't be possible for you to just falsify the entire blockchain. So that was just a parenthesis because I'm not going to enter into too many technical details, but obviously if you have questions after the presentation, feel free and we can go and discuss hash function and anything else. So here we see the padlocks and the key. Why is that? It's representative of the symbol that we use to vulgarize cryptography. A padlock is something that is not sensitive. You can put it on a door, you could put it on a bike, anyone can pass, check it, touch the padlock. That's not going to open. But if you have the key, then you can open the padlock. And that gives you a sense of property. So in cryptography, you have public key and private key. If you have the private key, you can de-encrypt any information that was sent to you encrypted by your public key. And so these are used in a blockchain to secure the transaction and to make sure that people, they speak with their own name. No one can speak for you because cryptography is also used for signature. So if I want to send a transaction to someone, I'm going to have to sign it. And in order to sign it, I need my private key this time. And anyone that knows my public key could run a mathematical verification and say that, okay, this person just signed this transaction. It is a mathematical correspondence to this public key. So it is indeed that person that just emitted this transaction. So you cannot lie. It has, I would say, a benefit and a downside. The benefit is that no one can speak for you. The downside is that you cannot say after, oops, that's not me that emitted this transaction. So that was, I would say, I hope so, a very easy introduction to blockchain. Now let's go back to the origins. Why are we even talking about blockchain today? We would be having this discussion if it wasn't for Bitcoin. So it's important to go back to Bitcoin. Bitcoin is a peer-to-peer cash system. It was invented, and it was not the first iteration of this idea of having a cryptocurrency, but it was invented after the financial crisis that hits and that made people distrust the banking system. Why? Because you live your daily life, you think you have money, you put it in a bank for safekeeping, everything goes well, and then one day, something happens, you go to the bank, and they tell you they cannot give you your cash. And so the question I'm asking is, was it really your cash to begin with, if it's the bank that controls it? So Bitcoins appear here because some people said, how can we basically do a peer-to-peer cash system? How can we send transactions to anyone in the world, just like I could give someone here some cash, but without going through intermediaries, with no middleman? So that's the idea behind Bitcoin. Bitcoin uses proof of work. Again, we can discuss about that, but just to give you a little bit of insight, it is the way blocks are validated. It has to, the miners have to perform a little bit of a challenge that takes approximately 10 minutes to solve. And through that, we can see if they're motivated enough to participate in the consensus. As a reminder, the consensus is what we've seen with the brother and sister when a brother or sister said, I want to insert my token in the tube. Do you agree that I have this right, that my transaction is valid? If yes, then we have a consensus. So that's the same thing on the blockchain. To say a few things about Bitcoin, obviously we don't know who created it. Satoshi Nakamoto, we don't know who he is, who they are, who she is, I don't know. Even though Craig Wright has some pretty serious claims on that. We know that governance is not easy on Bitcoin. We can discuss about that, obviously. Regulation as well. Pseudonymity. I think I'm going to highlight that point because of what I've been discussing with people today at the conference. Bitcoin is often painted as a very dark web kind of technology used for illegal things, etc. We need to put that in comparison with what it's aiming to replace. Are we saying that Bitcoin is worse, is helping trafficking compared to cash? No. More than 90% of illegal transactions done today in the world are done with cash. So if that's the argument, then let's not talk about Bitcoin. Let's talk about how do we delete cash from the world. If that's not the argument, then what are we talking about? The fact that people can do money laundering, hide behind some identity? Again, when you receive a bill from someone, you don't know where that comes from. We say in France, I don't know if it's the same in English, that money has no odor, you know, because you don't know where it comes from. Well, I can tell you that Bitcoin not only has an odor, it has a color, it has a timestamp, it has a hash, it has the public address of everyone. I can get a Bitcoin right now and go back to when it was first mined. We can go back to 2009 in terms of history of Bitcoin. This is maybe the best tool for cybercrime units and anti-money laundering task force. But that's not what you are going to hear from the media. Obviously, volatility is a drawback. Why? Because the market is small. So obviously, when someone starts selling Bitcoin, the price is going to change. When everyone wants to buy Bitcoin because they heard about it in the news, the price is going to change. So volatility is understandable because the market is small. And many cryptocurrencies are working on that, working on stable coins. So also that is going to change. So maybe I'll go quickly on this one. How can it work, like, to really understand? I think you need those 4 ingredients for Bitcoin. There is an effort. We've seen that with the proof of work. You spend your energy, you solve a challenge, you prove that you want to participate. And because you poured, I mean, you have to pay the bills, you know, you have to buy the mining equipment, you have to invest. Because you did that, we believe that your goal is to participate to the network. Why? Because of the reward. So miners on the blockchain, they're not just doing that because they believe in decentralization. They're also doing that because they have a chance of earning Bitcoins every time a block is mined. And if you know the current price of Bitcoin, and I put, I think, 12.5 Bitcoin, imagine how much money that is. So there is an incentive, and that's how it works. That's also maybe something that really drew me to blockchain technology, is that it does not only rely on tech to be secure or to work. It relies on how the human brain works. It relies on the greed. It relies on the fact that you want to earn money. It relies on the fact that sometimes you depend on others and you have to behave in a certain way so that money keeps coming to you. And this is why I put this sentence here, because people would say, well, if someone fakes the consensus, if a coalition appears between people and they all decide to put fake transaction in the network, everything could collapse. Yes, obviously in theory that could happen. In reality, why would they do that? Why would they kill their source of revenue? And this is why it's a theoretical attack, because the strategy that is going to make you earn the most money is being honest and following the protocol. We've seen other protocol public blockchain emerge in the last years. Ethereum, to name the second generation of blockchain. Ethereum was meant to be a world computer, able to do more than monetary transaction, able to run decentralized application. And so you could either redo whatever services you know in the real world, but in a decentralized way, or hopefully you could invent new ways of interacting that were not possible in the web that we know today. So it was very interesting, even though it reached some limitation, some security flaws. There is a lot of work that is being done currently, but it was a real paradigm shift at that point. Tezos comes as a third generation of blockchain. You can check it online, but basically Tezos takes the technology that are used currently, especially in, they come from academia in France and have been developed for the past decades, and they were used in industry, and they're used in nuclear industry, aerospatial, and it's basically based on formal verification. So to give you an example, let's say you're in a lift, you want to make sure that the doors of the lift won't open while it's going up and down. How can you make sure that your code is not going to behave in a strange way that you have not predicted? For the people here that are developers, I think you know what I mean. Sometimes you code something, you have an idea in mind, but you have not find out all the branches, all the ways that your code could be used by a hacker or just how a bug could happen. And so the technology used in Tezos enables mathematical proof and makes sure that the code is going to behave the way it was designed to be. So it's a stronger version of blockchain, and it opens a new era where money, big money, can be put on blockchain, properties, very serious thing, high stakes, can be used on blockchain. So back to Bitcoin, because I mentioned transaction. Well, what do I mean by transaction? I always take this example of Alice and Bob. Obviously, for Bitcoin, it's a little bit expensive for a book today. So Alice wants to buy a book. Bob says, well, yeah, we'll sell it to you for 4 Bitcoin. What will Alice do? Previously, Alice received one transaction of 1 Bitcoin. She has it in her wallet, electronic wallet, and 3 Bitcoin. And now she wants to do 4 Bitcoin. So she's just going to assemble the first transaction, the second transaction, and she's going to create another transaction of 4 Bitcoin that she will address to Bob. Money is not sent on Bitcoin. This is a misconception that I hear sometimes. You don't send Bitcoins. You just change the name of the owner on the ledger. That's it. So I put some fingerprint icons here. That is to tell you about this signature that I was telling you about earlier. That means that the protocol of Bitcoin is going to check if Alice has the right to use those unspent outputs that were addressed to her. It's going to check that when she's creating this new transaction and signing, the signature corresponds to the public key that was used to send this transaction to her. If it is a match, then she's able to create this new transaction, again, sign it, and then put the address of Bob in the transaction. Now, Bob has an unspent output of 4 Bitcoin that he can use, and when he's going to emit that transaction again and sign it, it is going to match because Alice put his address in that transaction. So you see how it works, and this is how Bitcoins are transferred. So, because I'm not sure I have the time, I'm not going to talk about double spending attack. So this is a recap of what blockchain is, what it brings. I insist that it's not a new technology because it's just a combination of old technology of cryptography, consensus mechanism, game theory, etc. However, it is a new way to think about how we design systems. It is not going to happen overnight. We've seen how long it took for the internet to provide the real use cases, what we call the killer apps. It would be weird to expect from blockchain to reach the same level of maturity and relevance in a shorter time. And again, it's just a medium. It's a way to build things. It's up to everyone here to come up with the idea of application that will be useful through blockchain. Some use cases. So, we've discussed about Bitcoin. Most people, they think about blockchain as a finance sort of technology, and it's completely untrue because blockchain can be used for many, many use cases. I give you here some example. For example, in the music industry, people can now post their release their album on the platform and write in a smart contract everyone that contributed to creating this music and the percentage. And when someone clicks to buy this album, the money is going to be transmitted immediately, for example, for 3% to the person doing the piano, 5% to the singer, 6% to the manager, whatever, and it's going to happen in real time. Today, it's not at all happening like that. And imagine for the industry of micropayments, when you just want to buy a song, when you just want to, for example, buy an article and you don't want to subscribe, how can you still reward the writers without subscribing to the whole thing? So it opens a lot of use cases. Just a question, is it the time that I have left? Really? Okay, sorry. I'm absolutely not going to be able to finish this presentation. So the hype. We've seen all these use cases. We expect that blockchain is going to be able to solve all the world's problems. Untrue. So what is the hype? You've seen probably the ICO bubble. So much money was poured into blockchain, just like it was the new internet bubble. It was crazy. BitConnect, if I had the time, I would have put you the whole video of the song. But yeah, check it out. So this led to the distrust that is now around blockchain technology, and it's understandable. However, use cases can be relevant on blockchain. You just need to know how to find them. I've done many hackathons. I've been teaching a lot in university and schools, and so I came up with this tool after answering always to the same question again and again. And so I encourage you to go check it out. It's called the Blockchain Canvas. It's basically on one page a tool to help you see if there is a relevance for your project to be on blockchain or if you just should use a regular database. Now the hope part. I told you about the kidney project that I was working on. The idea is pretty simple. Today, if you're suffering from kidney failure, and if you have the chance, if you're lucky to have someone in your family or friend that wants to give you a kidney, and you go to the hospital, you might find out that you're not compatible, which is a pity, and it is a waste. Kidner offers a matching platform worldwide where mismatched pairs of donor and recipient can still continue the journey and probably be matched with other pairs and create combinations so that, for example, on 3 pairs, you can perform 6 surgeries. Every donor is going to give a kidney. Every recipient is going to receive a kidney. People are going to be saved, but not from their own pair. And this unlocks a broken market, what we call a broken market, when offer is very, very, very low and demand is so high, which leads to trafficking and parallel markets. This can help have 50% of donor, 50% of recipients. So this is, I think it is a good example that blockchain doesn't stop at finance and can actually help much more. Because imagine if we can scale this to the world, hospitals can work together without the fear that a hospital is going to push their patient first or tamper with the calculation or the matching algorithm. Even the patient themselves. Today, they have absolutely no agency on what is going on for their file. They don't know if people are actually looking for a kidney for them. Through that, everything is going to be automatized. And if indeed there is a match, the thing is going to happen the same way it's happening today. So this is just a way through blockchain and cryptography that we use to protect the medical data. No sensitive data ever goes on the blockchain, which is also a good practice I would like to repeat. Through blind computation, we are able to find opportunities without disclosing anything private and helping on the same way people to get a transplant. Doing that is not easy, and I've worked on another project called Hellhound, which is a blind computation platform. So I'm going to leave you on that. Blockchain and the future of the web. So maybe you've heard of this notion of Web 3. I ask you this question, do you really own the data you produce? People and media, they always highlight hackers. I don't know why, but they're always from Russia. And it's like the big threat on your data comes from there. Truth is, the real threat on your data comes from your friends, the ones that are on your phone every day with you. I just included this screenshot so you can see what a lawyer did, trying to translate in human understandable language some bit of legal terms. Instagram policy tells you that basically, sure, you own your pictures and video, but we can use them if we want. And we actually can let other people use them without asking you, anywhere in the world. we actually can also make money out of your pictures and videos, and we will not give you anything for that. Thank you.